Hello again everyone, welcome back to this lecture tutorial which will continue on the empirical and molecular formula stuff that we did in the previous lecture tutorial. So just to recap and refresh a little bit, especially on the definitions. So candidates should be able to define molecular formula is the actual number of atoms, is the actual number of the different type of atoms in one single molecule. So that can only happen if you are simple molecular structure, meaning you must be a simple covalent molecule to begin with, okay? So our empirical formula is the simplest whole number ratio, so it has to be whole number ratio of the different atoms or the ions in a compound. In terms of the calculation that we did, there was a new formula that was introduced to you. It will become more and more obvious in the next bit of this topic, but unfortunately you have to just take my word for it at this point before we actually cover the concepts on mole and stoichiometry even further. So in the calculation of empirical formula, we are dealing with the simplest whole number ratio of different atoms. That's why this is always relative atomic mass, never ever relative molecular mass, because it's the simplest whole number ratio of atoms, not of molecule. Okay, so mole here, N equal to mass over AR. N refers to mole, the unit of which can be abbreviated as MOL. It's just a quantity of measurement. Is equal to the mass in gram, because the gram divided by gram per mole. This means your primary school mathematics, but just in terms of the units, they cancel out to give you mole, which is the same unit as on the left hand side here. Alright, in terms of what we actually did, I think it's better if I show you what we actually did. From the last lecture tutorials, we express an imaginary table which is laid out properly, label our atoms on top, and then label the masses with the units in gram, and then label mole equal to mass over AR, show the calculation, and then take the simplest ratio of the moles by dividing by the smallest number. So this number divided by the smallest number, which is itself is equal to 1. This divide by this smallest number give you 2. This is the simplest whole number ratio of the atoms in the compound. So I have Mg, 1 of it, and I have 2 Cl there. That's why the formula, empirical formula for magnesium chloride is MgCl2. And as we know from what we know about ionic compound in the formula, Mg2 plus Cl minus MgCl2 is quite legit, alright? There was this small, scarier looking kind of calculation. It's just a bit long, but all the process are exactly the same. And you could get the empirical formula, which is the simplest whole number ratio. 4:1:6:6. Remember what we did is the simplest whole number ratio of atoms is in terms of the mole. We actually did the mole, not the mass ratio, but the mole ratio. Okay? Now on to the next bit of this set of questions in these examples. So we have percentage of water in the magnesium sulfate crystal. Hope remember this thing when we did relative molecular masses as a hydrated compound. So it's hydrated because it has water of crystallization. So water crystallization, meaning to say you have certain number of H2O molecules that crystallize or co-crystallize together with one of it. So there's no number in front, this means 1. There is a number in front, that means N. Be aware that this is number of molecules. These are actually mole ratio. These are mole ratio, okay? So we have percentage of water is 51.2%. So if I have let the mass of the MgSO4.NH2O be 100 gram. So this is the percentage by mass of water. So therefore, the mass of the H2O, the water of crystallization, the percentage of water is 51.2%. So out of 100 gram, out of 100% is 51.2%. Out of 100 gram, then it will be percentage by mass. This is percentage composition by mass of the water is going to be 51.2 gram out of 100 gram. If that is the mass of the H2O, which consists of all of these NH2O, then therefore the mass of the anhydrous meaning not hydrated, meaning there's no NH2O, it's just MgSO4. The mass is going to be the difference from 100 minus 51.2. Pop that into your calculator and you will get 48.8 gram. So far, I have masses. I have masses of H2O. I have masses of MgSO4. So this is not strictly speaking the empirical formula kind of question, but I thought it would be quite interesting because you are just comparing mole ratio. You're comparing mole ratio of MgSO4 unit is to the mole of H2O, just like you're comparing the mole ratio of atoms here. We are comparing the mole ratio of MgSO4 to H2O there. So if I write the mole of H2O over the mole of MgSO4, if you look from here, for 1 mole of these, you have n mole of H2O. At the bottom is 1 because at the bottom is for the mole of MgSO4, there's 1 in front, and for the mole of H2O there's n. So for every 1 MgSO4, there's n moles of H2O. So this could be the other way around. If these are the other way around, if I label this the other way around, meaning to say the mole of MgSO4 on top over the mole of H2O, it's the exact same mathematics because equal is a very powerful thing. MgSO4, there's 1 of it, so my top is 1, and to the mole of H2O, so it's just 1 over n. If it is this way around, it's the other way around, n over 1. Okay, so it's just a bit of maths there. These are mole, these are mass. Do not confuse between mole and mass. So mole is equal to mass over AR, but mole is also equal to mass over MR. This is for compound, whereas when you did mole equal to mass over AR is for atom, because relative atomic mass was in the periodic, it is in the periodic table, as periodic table of the elements is for individual atom. It's a weighted average, it's average mass for all the isotopes relative to blah 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 blah, definition of which candidates are expected to be able to master completely, not just to be memorized like that, but to be applied and understood so that you can do in scenarios like these. Okay, so these are compound. So the molecular mass, the MR of H2O, as you did quite a lot in the last lecture tutorial, not the last one, I think the one before. So there's 2 times 1 because there's 2 hydrogen atom, 2 times 1, plus 16 times 1 because there's only 1 oxygen atom, so there's 18. And then I have the MR of MgSO4, so there's 24 times 1 for the magnesium, plus 32 times 1 for the sulfur, plus 16 times 4 for the oxygen. So there's 120 there. So on top, this is the actual mole of H2O. So that is something over 18. The mass of H2O is 51.2. This is gram over gram per mole. This gives you mass over MR. This gives you the mole of H2O actually present in this formula unit. The same thing at the bottom. I have the mass of MgSO4 without any water of crystallization is 48.8 gram. That was the difference, divided by 120. So altogether, I can hopefully see n over 1 is equal to n. So n is just equal to this over this. So pop all of that into your calculator and you will get 6.99. So of course, n is a water crystallization, it's a whole number ratio, so it's rounded up to the nearest whole number that will make sense after all. Okay, so mole ratio is not mass ratio because different substances have different molecular masses. Molecular mass, MR, is defined as the sum of the individual atomic relative atomic mass multiplied by the well, basically it's the sum of all the relative atomic mass of the individual atoms present, as stated in the last couple of lecture tutorials, I guess. Okay. So the next bit of this lecture tutorial is basically after we have found the empirical formula, then we need to find out what is the actual number of atoms present in one single molecule. That's the definition of empirical formula. So we need, what do we need? We need to know the entire relative molecular mass, all the relative formula mass. Okay, I'll show you an example. So this is the simplest ratio because this is empirical formula. So if I have CH2O, I don't know how many multiple of it. So it's like, how many multiple of N do I have? How many multiple of 2 hydrogen do I have? How many multiple of oxygen do I have? So the mass of this empirical formula unit is going to be 12 times 1 plus 2 times 1 for the hydrogen plus 1 times 16 for the oxygen. So all of that I'm going to multiply by N because I don't know how many multiple I need of this whole unit. The sum of the individual empirical formula unit multiplied by how many units I need is equal to the mass of the whole molecule by summing up individual relative atomic mass. So just like that, I have an equation. So 12 times 1 plus 2 times 1 plus 16 times 1, I get 30. 30 N equal to 60, so N is equal to 2. So if N is equal to 2, so that means my molecular formula, which is the actual number of atoms present in one single molecule, very, very important, one single molecule, is going to be multiple of 2. So altogether, my empirical formula, even though my empirical formula is CH2O, my molecular formula is C2, because 1 times 2, then 2 times 2 is going to be 4, and then 1 times 2 is going to give me 2. So this is molecular formula. By knowing the relative molecular or relative formula mass, then I find out how many multiple of the empirical formula do I need in order to get the molecular mass, the MR, and therefore I find out that multiple, and then I expand the empirical formula term by multiplying each and every one of the atoms present by that multiple. On to the next question. So we are asked to find molecular formula. So again, we have this empirical formula and they tell us the relative molecular mass. So C2H6O, N, meaning to say we have 12 times 2 plus 6 times 1 plus 1 times 16. So I want to know how many multiple of it will give me 46 as the relative atomic mass. So 12 times 2 is 24 plus 6 plus 16. So there's 46N is equal to 46. So N is equal to 1. And when N is equal to 1, so that means the empirical formula just multiplied by 1 unit. So therefore, it's exactly the same as the empirical formula. And it's not too surprising because, I mean, that could happen. So when it's just 1, you just think about whatever multiplied by 1 is itself. So the empirical formula here, empirical formula is exactly the same as the molecular formula. Okay, so it all comes down to the molecular mass. Question 3, which is basically the last bit of this lecture tutorial. So now they have given us the percentage composition by mass, but they haven't told us the empirical formula. These are most likely the type of question that you will get in the real exam, whether from Cambridge or any other 14 to 16 years old curriculum. They all like to ask these kind of questions, which are basically giveaway marks, provided you know what is meant by empirical formula, provided you know what's meant by molecular formula. They did not ask you to calculate empirical formula, but if you don't have empirical formula, how can you work out the molecular formula, even though you have the MR? Okay, so our first step really is work out empirical formula, which is the simplest whole number ratio of atoms. Okay, so these are percentage composition by mass. So percentage composition by mass means that out of 100%, these are how much mass is how many percent of it is the mass itself. So the mass per 100 gram, so meaning to say out of 100 gram, I have 66.7 gram of carbon, 11.1 gram of hydrogen atoms, and 22.2 gram of oxygen atoms. My mole, remember these are mole of atoms, they are mass over relative atomic mass of the atom. 66.7 divided by 12, 11.1 over 1, 22.2 over 16. So work that out on your calculator. So I get 5.56. So these are given all to 3 significant figures, 1, 2, 3, 1, 2, 3, 1, 2, 3. So I think it's appropriate for me to give my stuff to 3 significant figures. What is appropriate is a decision making based on the data that is given, okay? But these are not the final part of the question, so it really does not matter even if you don't give it to 3 significant figure, which is the case here. I don't give it to 3 significant figure because I can see that is my simplest whole, I can see that is my smallest number out of the 3 things. So I'm going to divide by this 1.3875. 11.1 divided by this smallest number, 5.56 divided by this smallest number. So that divided by itself is going to be just 1 because it's dividing by itself. That middle thing give me 8 exactly. And this thing here give me 4.01, which simplest whole number ratio. I can see that my empirical formula is the simplest whole number ratio of the different atoms present in the compounds is C4H8O. But they don't want empirical formula, they want molecular formula. So out of all of these, that means 12 times 4, okay? If I choose a different color ink, so that is obvious. So 12 times 4 for the 4 carbon, 8 times 1 or 1 times 8 for the 8 hydrogen, 16 times 1 for the 1 oxygen, and then that whole thing multiplied by n is going to be equal to the molecular mass, which is 72. So calculate whatever is in your in the bracket, 12 times 4 plus 8 times 1 plus 16. So I get 72n equal to 72. N is equal to 1. So what does that tell me? That tells me that my molecular formula is just the empirical formula. It's just this empirical formula with a multiple of 1, which means it's going to be itself, meaning to say C4H8O. That is the, I should probably put it down there so that it's clear without the confusion of the number 19 there. Molecular formula. So it's going to be exactly the same as the empirical formula because based on the MR, the multiple of how many of these empirical formula units do I have multiplied by n, it turns out to be n equal to 1. Therefore, I just have this whole thing multiple of 1. So it's C4H8O, which is exactly the same value as the empirical formula. Unfortunately, if you just write down these without showing this step, then you don't get the final mark to show calculate. You see, calculate. By stopping here, you are working out the empirical formula. You are not working on the molecular formula. To show or to get the molecular formula, you must, live without doubt by labeling everything very clearly so that the examiner cannot fault you because they don't want to read your mind. They are not mind readers. You want to outline every single thing very clearly and label very clearly. Even though I don't have a table with lines, that will save me time. But I have everything lined up properly. My handwriting is not the best in the world, but at least my working is readable enough for the examiner not to get confused and not to have to read my mind. Okay, so that's it for this lecture tutorial series on empirical and molecular formula. And for more examples on or variations on how empirical and molecular formula could be asked, you can catch the lecture tutorials, not a lecture tutorial, but just the normal tutorial on the associated work. I think it's work 2 or work 3, and it will be labeled as such for molecular and empirical formula. Okay, so thank you for watching, and make sure you practice these kind of calculations. Subscribe to the channel for more great videos. Click the button on the bottom right to do that, and follow me at ptet.chemistry on Instagram, Facebook, and Twitter to get connected. And don't forget to share the channel widely with all your friends, chat and study group, juniors and seniors from school, relative, and whoever else you think can benefit from these O-level, IGCSE level, 14 to 16 years old chemistry contents, as well as the other A-level, 16 to 18 years old contents on my channel. Alright, thank you for watching. See you in the next tutorial video.